Guys, welcome to Intro to Organic and Biochemistry. Now, some of you all may be thinking, hey, I'm not real sure what this class is going to be about. I know it's another high-level science class. I know it's got chemistry and maybe some biology type stuff in there. So what in the world are we going to be studying this year? First off, I'm super excited about this class. This is one of the brand new classes that we're trying out, and one of the reasons why I want to do this is that for those of you all that are going into the medical field or engineering or science or of course biochemistry, molecular biology, chemistry, chemical engineering, something like that. A lot of times what happens is students get to the higher level chemistry classes like say organic chemistry, biochemistry, particularly organic chemistry though, and they just sort of hit a wall because they've never seen this stuff before. And you're in a sophomore, junior level chemistry class, and the professor really expects a massive amount of stuff, and you've got so much stuff to memorize. You've never seen any of this stuff before. And my goal with this class this year is that I don't want that to happen to any of my students. I want you to get to college and you're in your first organic class and you're like, man, no problem. I know how to do names of ketones because I've seen those before. I might not have them all memorized already, but I know that. And I know about Friedel-Crafts acylation and stuff like that, that I know what these reactions are and I'm prepared and I'm ready. So that's what the point of this class is. But the point of the video today is we're going to talk just a little bit about what the heck does organic chemistry mean. Typically when you see the word organic, you think of something like Whole Foods Market or Earth Fare, and you think about, oh, am I going to get the organic apples or am I going to get conventional apples? And or were these things grown organically or conventionally? And what that typically means, of course, for us is that, hey, organic in common parlance means free of chemicals. And so then when you see something like organic chemistry, it sort of begs the question of what does it mean, right? And obviously then organic has to have a different meaning for us in science. It doesn't mean free of chemicals, or it wouldn't be anything called organic chemistry, okay? So, when you're in this class, you need to get the idea out of your head that organic means that it's grown in a certain way or that it's, that there's no chemicals involved. Organic chemistry obviously is about chemicals. So essentially it goes back to, if we think back to where chemistry sort of got its start, it got its start with these guys called the alchemists, okay? Now, a lot of people don't like to say that because they're like, well, what the alchemists were doing wasn't science. But really it was. I mean, the alchemists had this, they had this strange amalgamation and hybridization of scientific things and spiritual things, and they were trying to jam them together. And what the alchemists were trying to do is they were trying to say, hey, we can break down the mysteries of life by doing sort of some things that we would classify as chemistry today. Now, they had different goals. Their goal wasn't necessarily scientific knowledge. Their goal was to, can we make the philosopher's stone so we can get immortality? Can we turn base metals into gold so obviously we can get rich? But a lot of what they did, a lot of the techniques that they developed then go on to become modern chemistry eventually when we get into the 1700s. One of the ideas that they had that really went through even up to ideas of modern science was this idea of vitalism. The idea of vitalism was that there are chemicals of living organisms that are unique and that there's something different about them because they come from living organisms. And those are different than, say, chemicals from non-living organisms. And so we might have acids that we get from mineral compounds, and that's going to be therefore different than the chemicals that we can isolate from living organisms. And so if we're pulling proteins and DNA and stuff like that out of living organisms, that those are fundamentally different than the chemicals that are in non-living organisms. The idea behind this is that there was some sort of vital force in these organic chemicals, okay? And those would be the chemicals that came from living organisms. That's where the word organic sort of originally gets its idea in chemistry, is that it comes from living organisms, or that they had to be living at one point for us to get those chemicals. And of course what goes along with that is that there is a vital force there, that there's something there that makes them unique. And really this was the thought process for really hundreds or thousands of years, is that living organisms had different chemicals than non-living organisms. This sort of falls apart in 1828 when this guy, Friedrich Wöhler, totally accidentally synthesizes what was previously known as an organic molecule. Urea is a molecule that we find in our urine. That's sort of the urea idea. It's a nitrogen-based molecule. It's one of the ways that our body excretes our excess nitrogen. But Wöhler was doing a completely different sort of thing in the lab, and he accidentally synthesized what he knew to be urea, a compound that had only been isolated from urine before. He wasn't dealing with anything that was in any way from a living organism. And so what he discovered here is that, hey, obviously I've got the same molecule here, this urea that I've got, that I synthesized, okay, made from non-living things, is exactly the same as urea that we get from urine from living organisms. And so therefore, if they're chemically the same, then there must not be a vital force there, okay? If they're going to react in the same way, then that means that they have to be okay. Really, really what this should do is dispel the idea of vitalism. Now, it still takes 100 years or so. So prominent guys like Louis Pasteur, like Berzelius, who was a big chemist back in those days, they still believed that organic molecules were fundamentally different, that they had to come from living organisms. And really, to be honest, a lot of people still believe this today. I mean, like, well, if I get my vitamin C from oranges rather than from a synthesized vitamin, then it must be different, right? Well, really, no. Vitamin C, ascorbic acid, it's the same thing. It works in your body in the exact same way, whether it came from an orange or whether it came from a vitamin. Now, you might get some other benefits from eating oranges that are aside from just the vitamin C, but the molecules themselves are the same, okay? So essentially, Wöhler is sort of the first step that we get in synthesizing or dispelling the idea that molecules from living organisms are fundamentally different in some way than molecules from non-living organisms. Well, here's the problem. If that's not it, then what does organic mean then? If it doesn't just mean from living organisms, then what does organic mean? Well, I'll tell you one thing. It does still mean to a large degree that a lot of the compounds are synthesized from living organisms or have an analog in living organisms or once living organisms, like petroleum. Okay, petroleum obviously is the result of the decay and chemical change of living organisms as they're compacted over time. That's not what it means anymore totally, but it still sort of has some of those connotations. So if I had to give you a firm definition of what is an organic molecule, I can't. No one really can. I can give you some hints though. Essentially for us, an organic molecule has to contain a significant amount of carbon. It's got carbon in it. We tend to not call molecules organic if there's no carbon in them. And specifically, generally, a lot of people would say that most of them have to contain a carbon-carbon or a carbon-hydrogen bond in some way. And obviously, we'll talk more about bonding as we go throughout the year. So, that being the case, what's not? Does it just mean anything with carbon is organic? Sadly, no, because that would make it a lot easier. Typically things that are carbonates or things like carbon dioxide, oxides, simple oxides of carbon, not organic. Cyanides, alloys like steel that have carbon in them but aren't really covalently bonded molecules. Those are we're going to classify those as inorganic, meaning not organic molecules. So just a real brief rundown here of sort of the split here. This is a fuzzy thing, right? But it will become clear as we go throughout the year. And there's still debate. I mean, there's debate. It's a molecule like Teflon that has carbon in it, but not much, but, a lot of fluorine, a halon, essentially. Is that organic or is it not? It kind of depends on who you talk to, really. But in general, things like methane, ethane, butane, propane, sugars, gasolines, alcohols, formaldehydes, citric acid, things like that are organic acids. Those things are going to be organic. Why? Carbon, a lot of carbon bonded together, probably some carbon-hydrogen bonds. Inorganic instances of things with carbon, if it's a carbonate, okay, so you recognize the carbonate polyatomic ion, that's an inorganic molecule. Carbon dioxide, carbon monoxide, those are considered inorganic. Typically speaking, allotropes of carbon. So some other examples of something like that would be something like graphene, okay, or diamond. They're just different forms of elemental carbon. not organic. They are inorganic by their nature. And again, people could probably argue about that as well, but in general, we would classify those as inorganic. Okay, so great. That takes care of the organic part of the class. We're going to be talking a lot about junk that has carbon, right? Okay. So what about the biochemistry part? You know what? This part's pretty easy. We're going to be talking about molecules of living organisms. And you're like, wait a minute, didn't we just say that organic? Okay, forget that. Biochem means molecules of life, so molecules of living organisms there. So what kind of things are those? So nucleic acids like DNA and RNA, okay? Proteins like hemoglobin. Carbohydrates like starches, sugars, glucose, those kinds of things. Those are biochemical molecules. And then lipids, fats, oleic acid, hormones, and stuff like that. All of those things are going to be what we call biomolecules or biochemical molecules. And that's the sort of stuff we're going to get into in the biochemistry part of class. So I am like super excited about this class, guys. Here's the good news. This is a brand new class. So there's not like a state test at the end of the year. There's not like an AP level test at the end of the year. But this class, it's not going to be a college level class, but it's going to be a high level class. It's going to prep you for college level class. And I'm really excited, guys, about us getting into this class and about learning about essentially molecules of life and really just a lot of really important molecules to us in the case of organic molecules. So I hope you'll join me throughout the year, guys, and we're really going to enjoy this.